Hello and welcome to Waka Breaking It Down. Breaking down the 2003 AP Statistics Form B, number 1. This is talking about the 9 students at a large university. Sometimes the word large is important. Each of the students reported the number of hours he or she had allocated to studying and the number of hours allocated to work. So we're doing studying versus work. You'll see they have a scatter plot here, work and study. And they labeled this piece, so I can tell right away we're going to be talking about influential points. They have these kind of a clump, and then they put a point way over on the right. And we're probably going to be talking about how this moves around or how it affects the graph, which is what we're doing. So they give us a printout, things that we have to recognize whenever it says constant, that's the y-intercept. Whenever they have the variable, this is the explanatory variable that goes along with the slope. We don't really need to concern ourselves with this stuff yet because we haven't done inference yet. But you guys know how to work with a p-value for slope. Well, kinda. You know how to work with a p-value, and this is the p-value for slope. So maybe I'll briefly talk about that. The R squared adjusted is for multiple regressions. We're not doing that either. So I'd really ignore all of this stuff, ignore that. Maybe talk about this P, but really you can just focus on these values right here, right? The y-intercept, the slope, and then R squared, our coefficient of determination. You can always take the square root of that to get your R value, your correlation coefficient. So those three numbers are really going to be what we focus on when we talk about how an influential point affects the regression model. Okay, so let's get to the actual question. That's down on the next page here. So A, after point P labeled on the graph on the previous, it was removed from the data set. And you'll see later here they talk about how it was a mistake, right? And they're going to change it. So it was a mistake, so they're going to remove it from the data. So they remove it, and then they do a second regression model. So does point P exercise a large influence on the regression line, right? So we're just saying, is it large influence? Well, there's ways you can figure that out, and there's like 4 different things, maybe 5 different things you could say. But like I said, let's focus on these 3 to begin with. First of all, you have to say, yes, they asked the question, does it exercise a large influence or not? You have to say, yes, it does. How do we know, though? How do we know? Well, a couple things. The mass of this blob right here is kind of right in here. And the p-value is far, or that p point, sorry, it's not a p-value. The p point is far away in the x direction from the rest of the data. So anything that's far away in the x direction always will have influence. The other thing is kind of the reason they set this up the way it is if you remove it, does the slope change? Does the y-intercept change? Does your correlation change? Does your test change, right? So there's like 4 different things you can kind of look at. So let's go through them. Before we remove the point, I'm going to focus on the slope first because that's probably the most important. So I'm going to focus on this 0.49 to begin with. The slope used to be 0.49. This would be kind of a, let's see, a slope of 1 would be kind of like this. That would be a slope of 1. But we have a slope of about a half. So it's going to be like, for 10, it's going to be like 5, Well, it's not going to be exactly like that, but it's going to go up a little more shallow, right? It's going to be more like this. But that used to be our slope before we removed the point. The other thing I noticed is that the y-intercept is 8.1. So right here, I have 8.1 as my y-intercept, and it kind of goes up as a half as a slope. All right, and the correlation of this is 40. The coefficient of determination, the variation that's been removed, is 47%. All right, so when I look at the new list down here, the slope is only 0.15. So it used to be 0.49, and it's now reduced to 0.15. So my slope, this is the new set down here. Well, you can use the old set. Yeah, sorry. Jumping around. So if you ignore P, like it's gone, my slope, used to kind of go up like this or something maybe, but now it's like really flat now. So that's what you want to mention. The slope is significantly smaller. It's still a positive slope, but it's definitely decreased. And also then the y-intercept. The y-intercept used to be 8.1. Now when we look, whoops, we have 11.1. So it went from like 8.1 here with kind of a higher slope. It went up to 11 something with maybe a flatter slope, right? So that's the difference. And you just have to describe a couple, like two of the many things, of the four things you could talk about, you have to talk about two of them, right? So I would just mention the slope is smaller, it decreased, and also the y-intercept increased. We could talk about r squared as well. That's actually a really good one to talk about. So the coefficient of determination, we've only removed 2.5% with the new data set, when before we had removed 47% because that point was in there. So you can talk about two of those three things. Let me show you their answer real quick. Right, so the point P does have an influence, so you have to say yes. You can't just go into it. You have to say yes, right? And then they talk about, like I said, they talk about how the slope changes, and then they talk about how the y-intercept changes, and they talk about how r squared changes. You only have to have two of the four things they're showing here. They show four things, but you only have to talk about two of them. The last one they talk about is the significance, which is not, like, we haven't done inference yet, so don't worry about it. But what they're talking about is this used to be 0.04. When you're doing a test, that means this p-value is low, which means I have evidence to suggest the slope is not zero, that there really is an association going on between work hours and study hours. When we look at the new graph, the p-value is like 70%. So that fails to reject the null hypothesis. We do not have evidence to show that there's an association between work hours and study hours. So we don't see that association with this because it fails the test. All right, so that's the long answer to the to A. This is a number one question, so it really should be short and sweet, but I just want to explain everything thoroughly for you. Okay, part B. So now they say, oh, the point P really was a mistake. We fixed it, and now the real value Q has been put on the graph now. All right, so, and then they say, explain how the least squares regression line would differ from the original. Well, P used to be way up here. Now it's way down here. When I look at my, this, by the way, this readout is not for part B, right? So they don't give us the actual data. They're like, I don't know. I don't know what it is. But if you were to try to look at this and try to make a regression line, it's pretty obvious that your regression line would come down like this, right? Somehow or another. So you're going to end up with a negative slope. And that's exactly what they want you to measure or talk about. They want you to say, hey, my slope used to be positive because that p point, and now my slope is going to be negative because of Q. So obviously that point is very influential. You move it from one position up top down to a position below, and you're going to change the slope from a positive slope to a negative slope, which is a big deal. We're always looking for association. Is it a positive association, negative association, or no association? And this changes it from a positive to a negative just by moving one point. All right. Now you can talk about the y-intercept is going to get higher. You can maybe mention r squared, but really I wouldn't do that because the correlation isn't really going to change much. It's just, well, it is. It's going to change like from a positive to a negative, but the value isn't going to change too much. So let me show you their answer, part B. So the regression line for the corrected data will have a negative slope, and that's the important piece, saying it's negative. You can't just say it changes. That's not enough information. You have to actually say it changes from negative, changes to negative from positive. So that's a big change, right? And it does say the intercept would be much larger as well if you want to add in a little extra. But when you really go through the scoring guide, they don't make you talk about a whole bunch of stuff. You can just talk about the slope, right? You can't just say the slope is lower. That would only get you a P. You have to actually talk about the sign of the slope changing. All right, that's 2003B number 1, right? Influential points.